All right, so all of the sequence and series that we've been talking about has to do with growth or decay. Okay, so the first one we're going to look at is arithmetic sequences. So you've learned that it's a pattern of where I'm adding or subtracting the same values. So guess what it's going to draw as a picture if I'm adding the same number or subtracting the same number over and over again. So in other words, if I start here, I'm going to increase by the same every time. What is that going to draw?
Stairway.
Not.
That's what you do.
If I connect the dots, a line. An arithmetic sequence is a sequence of linear growth. Okay, so, oh my goodness. Help me. Help me. All right, so we're going to look at population growth first. Creating mathematical models that demonstrate both positive, which means my population's increasing, or negative, my population is decreasing or decaying. Okay, we're dying off. So, populations can be human, animal, plants, inanimate objects, okay. All of these have some kind of a population growth or decay. Okay. I usually go back to, you hear about species being endangered. That's because their population is decaying. Okay. Most of you learned in history class about the baby boom.
Nope. Yeah. Oh yeah, yeah. I was gonna say that. Hold on. At first I was like, wait. Yeah, I know what you're talking about.
When like every woman in the US just started popping out babies left and right, left and right. So all of a sudden our population went from this to boom, there it is. Okay.
Show about that.
Is there?
Yeah, some girl had a baby out of nowhere. Especially during World War II when they came back out of the war and did.
Who? Babies. Who's your history teacher?
Johnson.
Oh.
And we've talked about this in class.
And he likes YouTube, so I think I'll send him the link. By the way, Kimberly doesn't actually pay attention in your class. She admitted it on YouTube.
I mean, I do the work, and I get the grades for the work. That's all that matters, right? Right? Getting the grades. If you don't comprehend it. You don't have to comprehend it.
Okay, so we have something called continuous growth. What do you think continuous growth means?
It continues.
It continues. So it is a pattern of growth that goes over and over again. So the dynamics of change are in effect at all times. It continuously grows. So this blank is all times. And that's just another way to say continuous. We also have something called discrete growth. This is a sudden change in population after a certain period of time. And my board's off already. Whoop, whoop. Okay, so discrete growth would be the baby boom. Okay, we don't have a baby boom every year. It's not continuous. It was all of a sudden, poof, there's all these babies. Okay. Transition. Transition is the regular interval of time between changes in population. So, like every 3 months, every year. Okay? How often does this happen is your transition?
anybody watch Jessica Jones?
Nope. Yeah, I watched the first season.
I don't understand it. Like I'm on the second episode and it's just wild. Like.
And your discrete growth example is the baby boom.
I watched the first one. I remember being really good.
Yeah, like I think it's pretty cool. But I don't.
Okay. Or another discrete growth example would be you hit the lottery for $20,000 and you deposit that. You're not getting $20,000 every week. It's not continuous. It's all of a sudden you win all this money. Yay, you! If only we could all be that lucky. Okay, so some of the things we're going to be able to talk about in this chapter. What's going to happen to a given population over time? Is it going to die off? Is it going to increase?
It declines.
Okay. What are the long-term patterns of growth, if any?
Slow impact.
Okay. Your transition rule. This is the same thing as your recursive rule, which is why we did chapter 9 first. Your transition rule is the same thing as your recursive rule. It tells you when the change happens and how it's being changed. So now instead of calling it an arithmetic sequence, we're going to call it a population sequence. Okay, so P sub 0 is going to be your initial population. So the first number is your initial population. Okay, that's your initial population. And P sub n represents the size of population after n transitions. Okay, the size of the population after n transitions. So the next page, we're going to look at some problems and what you're going to have to deal with. We got 2 examples, and we done.
Yeah.
Whoop, whoop.
We have a whole thing.
2 examples. Wah,
That's a whole thing.
wah, wah.
I'm just saying, whenever you say, "Oh, we only got,"
Yeah, all right.
you just say a whole page.
Oh.
It's always
All right.
A, B, and C.
Right. All right. So the number of cars produced is expected to increase by 25 every 2 months. If the company started with 100 cars, find the population sequence. Okay. So what's my initial population?
100.
100. After 1 transition, how many?
125.
After 2 transitions. After 3 transitions.
175.
How'd you get that?
Adding 25.
Adding 25. It says we're increasing by 25. So that means my transition rule is A sub n minus 1. I'm taking the previous number and I'm adding 25. So I'm taking 100 and adding 25 to get here. I'm taking 125 and adding 25 to get here. I'm taking 150 and adding 25 to get here.
Wait.
That's what this tells me.
What is it every 2
Yeah, every 2 words. That's just additional information.
Hold on. We're getting there. I am getting there. I promise. Okay. So y'all just said, well, it says every 2 months. So my transition then is 2 months. Okay. So that means at n sub 0, I'm at 0 months. At n sub 1, that means 2 months have passed. At n is 2, 4 months have passed. And at n3, 6 months have passed. So from January to June, my population jumped to 175. So every time my number increases by 25, we've gone 2 months into the future. So we've started in January. This is now March. This is now May. This is now June. Okay. So that's what that means. And that's where that filters in. Okay. Let's see if we can answer these questions now. How many months have passed if we're now at P sub 9?
18.
How'd you get that?
2, 4, 6, 8.
Okay. You can literally sit there and count it. 2, 4, 6, 8, 10, 12. 9 times 2, because we're 2 months, 18 months. Okay, we're 18 months in the future.
You know what I feel like watching when you said that?
What?
Scooby-Doo.
Oh. Scooby-Doo. Scooby-Dooby-Doo. What is the number of cars produced after 5 transitions?
225.
Beautiful. So we stopped at 3, which means 4 is 200, which means 5 is 225 cars. Okay. Be careful with C. What is the number of cars produced after 1 year?
400.
What'd you say, Kim?
250.
It should be 250. Okay, remember, this is happening every 2 months. So if it's happening every 2 months and I'm a year, how many times has it happened?
6.
6. 1 year is 12 months divided by 2. So that's 6. So I'm actually looking for P sub 6. Okay, that's where that transition comes in. Okay, you've got to think about how often it's happening. So if it's happening every 2 months for a year, it has happened 6 times in the future, which then makes this 250. Okay. Is this easier than what we did yesterday?
Yes. Very.
This is what your test is going to focus more on than yesterday.
Yeah.
So are you that scared of this test now? Just a tad.
I just want to graduate.
You just want to graduate. Amen. Amen.
You know what sucks?
What?
I'm not getting the honor cord, which is stupid because I got like all A's and all B's in all my classes except for 4. Oh my, I'm failing that class.
All right.
That's how bad.
Let me just tell you before we do this problem. I want to be Michael. If somebody could make me Michael, I will take you with me.
What?
Because we have buku bucks if we are Michael. Just so you know.
Do you mean?
Okay, so Michael's expected to double his profit every 6 months on his investment and has already earned $120 in profit. Okay, so that means P sub 0, my equation or my sequence starts at 120. I've got to fix this board. It's driving me nuts. So what does it mean if it says he's doubling?
120 times 2.
Times 2. So his next number is?
240.
240. His next number is?
Hold on. Oh, 480.
480. His next number is?
960.
240. 480. 960. Okay. And it's going to keep going on and on and on and on. So my transition rule, you said doubling means times 2. So 2 times your previous number. 2 times a sub n minus 1. What's my transition in this one?
6 months.
6 months. Which means how many times a year then?
2.
Twice. Twice a year. Every 6 months means twice a year. So it says, how much profit is Michael making in the 8th generation?
have no idea.
So right now, we've got, this is P sub 0, this is P sub 1, this is P sub 2, P sub 3. I still need 4, 5, 6, 7 before I get my answer.
Okay, you
Alright,
do
so
8
the next one
times 6 times
The
2.
next one is
next
19,
one, 19.
Okay, you said 1920.
is 38, 40.
I thought you were gonna give us a way that you would do
38,
that.
40.
Me too. Then it's 7,680. 7,680.
Okay,
Then it's 15,360.
15,000 what?
15,360.
38,700.
30,712.
After 8 generations, he now has $30,720.
That's kind of a long wait.
How many years is that?
Only 5.
4 years.
4 years. 4 years. If we've gone 8
Oh, right.
generations, that means we've gone 8 groups of 6 months. 8 divided by 2 times a year gives me 4 years. Okay. So 4 years in the future, he's made a profit of $30,720. I guess that really isn't that much. But I mean, if you keep going, that's going to double real fast.
So what the next one should be 15,000.
Okay. So after 4.5 years, he'd have 60,000.
5 years he is.
Like he's making buku.
5 years he is.
Okay. So part B. How much profit does Michael make in the 3rd year of investing?
7,680.
Good. This is your 3rd year. Okay. $7,680. How many years into the future does P sub 36 represent for Michael?
36 divided by 2 equals 3. No, hold on. I'm trying to do the math in my head.
What's 3 divided by 2?
37.
How many times does 2 go into 3?
1.
With 1 left over, how many times does 2 go into 16?
Just like
3.
you hit me over right now.
I mean, like,
How many?
I
16
can't.
divided by 2 is what?
8.
Hey,
Oh, I was trying to do the
goodness gracious. Sorry, I did not hear you over 5, 3.
Like, I was doing like the.
Goodness gracious. Okay, so if they want to find P sub 36, we're looking 18 years into the future.
We're done like the second half.
Okay. So what I want you to work on is the actual 9.1 homework assignment on the back of that package. Please, somebody text Sammy and tell her that. Oh, actually, I should probably email her because they probably took her phone.
Who's she? Isis?
Yeah.
Oh.
So I will let her know.
She is.
Okay. Tomorrow, we're going to look at actually finding numbers. You'll be able to use the equations I give you tomorrow to find the 76th number in the sequence without sitting there and going plus 12, plus 12, plus 12, plus 12, plus 12. Okay. Tomorrow is the shortcut.
We're gonna do, well,